Good morning, students. I hope you all are well and doing your study continuously. We are doing linear algebra, and linear algebra is the study of vector space. To understand the vector space, we have to revise some basic concepts, and we are doing that. We have introduced algebraic structure, binary composition, and some properties of binary composition. Due to these properties, a particular set with binary composition is known as group, ring, field, etc. So let us continue this. Algebraic structure, a set or sets equipped with one or more than one. Binary composition. What is algebraic structure? A set equipped with one or more than one binary composition. Group, ring, field. Composition is internal. That means it is G cross G to Z. Here it is R cross R to R, two binary composition. Here it is internal binary composition. It is this. Whenever we add two numbers or to perform the composition as addition or multiplication or division, we require two numbers, and these two numbers be taken together in the form of pair. That pair is known as ordered pair, and this you find here in this. So whenever the set is given, suppose Z be a non-empty sets. In first step, the nature of the elements of set Z. The nature of the elements of set Z means elements may be numbers, natural numbers, integers, whole numbers, rational numbers, irrational numbers, real numbers, whatever it is. So elements may be numbers, may be matrices, may be vectors, etc. So as soon as you people are given a set, then you find the nature of elements of Z. Okay, then next one, find the rule of the binary composition. Means that means addition, subtraction, multiplication, etc. Find the rule of the binary composition. So if I write, then here n set of natural numbers. This is binary composition. Set of natural numbers, nature of the elements, numbers. Which type of numbers? Natural. Which type of composition? This is the sign denoted by this composition, and here it is addition. So this binary composition this one. Here you find the elements. You'll find elements like this, A comma B, where A and B both belongs to N. So in this set you will find the elements in terms of pair. So the image, because this is the function, so image of this will be in this set. So here I write image of A comma B is denoted by under image of this is denoted by this in N under the composition plus. If this is denoted by star, then here it will be star. So in general, then here it is A cross A to A comma B. Image of this will be A as this B. Okay. This is the set of this. This is the set. This we have already done. Now, since binary composition is a function, so every element of A cross A is associated with A uniquely. We have done the composition table and some properties of that. Let us see one particular example. Prove that the multiplication composition is closed in 0, 1. Multiplication composition is closed in this particular one. Remember, this is the closed interval. So let's this is the set, given set. Composition is multiplication. Be careful, I am using the word multiplication, gunan. Okay, so here is the symbol. J cross J means any two members of this 0, 1, and the answer must be in this. Suppose I consider one member is 1 by 2 and other member is 3 by 4. For example, it is this. So if you multiply this, it means 1 by 2 into 3 by 4, then your answer is 3 by 8, that belongs to Z. That means 3 by 8 belongs to 0, 1. This is the particular example, but it must be true for all. I am again telling you, it must be true for all members which are in G cross G. And if I say how many members lying in this one, then there are infinite number of elements. So this is not the particular method to so that this multiplication is closed, this composition is closed. So how to proceed? Suppose x, y belongs to C. That is this one. Therefore, x is lying between this, or I write x belongs to and y belongs to. This implies positive. Look at this. Y is lying between 0 and 1. So y is positive, may be equal to 1, may be equal to 0, that is different thing. So if we multiply any inequality Samika by positive number, then sign of inequality does not reverse. Therefore, we multiply this by y. So it is 0 xy and here it is y. But remember, this y is less than or equal to 1. Here you can see. So here it is, this one. Y is greater than 0. Of course, we are getting this, and this is less than 1. So this implies this quantity is this. This means xy belongs to 0, 1. This implies xy belongs to z. Therefore, for all xy belongs to z, implies x into y belongs to z, or for all xy belongs to this goes into implies xy belongs to 0, 1. Therefore, multiplication is closed in 0, 1. So multiplication is the binary composition in this closed interval. Okay? Now remember, here we people are playing with numbers. We can play with matrices. We can play with vectors. You have studied theory of matrices. Two matrices can be added or subtracted if they are of the same order. Okay, now listen. Let Z be a set of 2 by 2 matrices belongs to R. Set of but to write like this, square matrices of order 2 by 2 with real entries. Means elements of matrix be real numbers. Now we can add two matrices. So let A, suppose I say 2, 3, minus 1, 4, and B another matrix, suppose 1, 1, 0, minus 1. Then find A plus B, or better to write M1. Here is M2. Then M1 plus M2. This is 2 plus 1, 3, 3 plus 1, 4 minus 1 plus 1 here. This is also a square matrix of order 2. Okay, so matrix addition is closed. So here it is plus sign. This is B cross Z to C, and he will find order pairs means just like this, M1, comma M2, and this is the image of this, and here you find M1 plus M2. So the image of this one is this. This is the set of matrices. इस पूरे सेट में केवल मैट्रिसेस है. जैसे आप हाथ डालोगे इस थैले में से उठाओगे तो एक मैट्रिक्स मिलेगी, और उसका ऑर्डर क्या होगा? उसका ऑर्डर होगा 2 बाई. इसमें भी मैट्रिक्स है, लेकिन दो मैट्रिक्स एक साथ है, पेयर है, और इन दोनों के बीच में जो कंपोजिशन कौन सा है? वो प्लस है. सो इफ वी ऐड 2 मैट्रिसेस, द आंसर इज अगेन द मैट्रिक्स. सो दिस इज closed. But I am interested in other part of this. This is internal composition. Okay. Remember, you have done in previous class, if n equals to 2, 3 minus 1, 4, then find 2n. अभी तक आपने जितने भी एग्जाम्पल्स लिए थे उसमें दोनों मेंबर्स जो थे वो एक ही कैटेगरी के थे, एक ही नेचर के थे. या तो दोनों नंबर्स लिए, या दोनों मैट्रिक्स लिए, या दोनों वेक्टर्स लिए, एक ही जैसे लिए थे, या दोनों सेट्स ले लिए, या दोनों फंक्शंस ले लिए, या दोनों पॉलिनोमियल्स ले लिए. यहाँ अलग है, लेकिन प्रीवियस क्लास में आपने इस पे ज़्यादा ध्यान नहीं दिया है. यदि मैं इसको लिखता हूँ 2n means it is 2 times 2, 3 minus 1, 4, and you people know that how to multiply a number by a matrix. So you write it is 2 into 2, that is 4, then it is 6, then it is minus 2, and here it is 8. Again, this is a matrix of order 2 by 3. Now my question is, here you find the matrix, here it is a matrix, composition is plus. This is a matrix, this is a matrix, composition is plus, but here you find this is a number and this is a matrix. Remember, this is a number and this is a matrix. You will not find this situation in this part. M1 is from this, M2 from this. Pair of two matrices. I do not want a pair of two matrices. I want first component इज ए नंबर। मुझे पहला मेंबर नंबर चाहिए और दूसरा जो है मेंबर मुझे मैट्रिक्स चाहिए। इसका मतलब ये हुआ कि यदि मुझे नंबर चाहिए तो मुझे वो सेट लेना पड़ेगा जिसमें नंबर्स मिलेंगे। दूसरा सेट मुझे मैट्रिक्स चाहिए तो मुझे दूसरा सेट वो लेना पड़ेगा जिसमें मैट्रिक्स हो। और इन दोनों का जो आंसर है वो वापस किस में आना चाहिए? मैट्रिक्स। Then I want this set particularly. So here you can see and one thing more, look at this. The sign between 2 and m is multiplication, but it is not ordinary multiplication. It is not the multiplication of two numbers. It is not the multiplication of two matrices. This is the multiplication of number, that means scalar. It may be positive, negative, whatever it may be zero also. So here this is not the ordinary multiplication. The sign is not kept here, but you have to remember this is the number and this is the matrix. Nature alag hai. And this multiplication is known as scalar multiplication. Scalar multiplication of matrix. ध्यान रखना है, मैंने वर्ड मल्टीप्लिकेशन यूज नहीं किया है। यदि मैं वर्ड मल्टीप्लिकेशन यूज करता हूं, मैं वर्ड गुणन यूज करता हूं, इसका मतलब मल्टीप्लिकेशन साइन के इधर और इधर दोनों तरफ एक ही नेचर के, एक ही स्वभाव के एलिमेंट्स होंगे। मैट्रिक्स है तो इधर भी मैट्रिक्स, इधर भी मैट्रिक्स। नंबर है तो नंबर और इधर भी नंबर, वही जिस सेट से है वो। ये बिल्कुल डिफरेंट है। दिस इज ए नंबर, दिस इज ए मैट्रिक्स। यू हैव डन इन क्लास 12th हाउ टू मल्टीप्लाई अ मैट्रिक्स बाय नंबर। वहां हमने बहुत आराम से किया था, सोचा ही नहीं था कैसे मल्टीप्लाई करना। सारे नंबर्स को मल्टीप्लाई कर लो, आंसर मैट्रिक्स आएगा। लेकिन वो नंबर कहां से था, वो मैट्रिक्स कहां से थी, इसको हमें थोड़ा सा डेप्थ में देखा है, माइन्यूटली इसको ऑब्जर्व करना है। सो हियर यू सी दिस इज स्केलर मल्टीप्लिकेशन। आई पुट द मल्टीप्लिकेशन बाय डॉट्स। This is a number, so definitely it belongs to a set which is full of numbers. So here I write F, or maybe this is, right, this is a set of real numbers. Okay, second set of matrices, suppose it is C, for example. Set of matrices. Number, answer is in C. Set of real numbers, set of matrices. Look at this. It is different from this G cross C. This is internal composition, and this is external composition. External. Is it okay? and this composition is denoted by this dot. In here, dot is known as scalar multiplication. Okay, so be careful. Whenever you are given the algebraic structure, first we find which type of set is given, what is the nature of the elements. Second, how many compositions are given, 1, 2, 3, 4, whatever it is. Again, is it internal or external? So here it is external composition, here it is internal composition. Internal composition, the function is from this to this. External composition, find this one. And the situation you can say, whenever you have to multiply a matrix by a scalar, that means you want a scalar and matrix both. So one is from scalar set and other is from matrix set, like this. The similar example is in the form of vectors. Two vectors can be added, just like two matrices can be added like this. But if we multiply a vector by a number, say suppose I write vector k 2i minus 3z plus 4k, and I say find it is a similar thing. Remember, there is no symbol. Here it is. This is scalar multiplication of a vector. Just like scalar multiplication of matrix, scalar multiplication of vector. 2 is from this set. Vector is from this set. Final answer is a vector. So whenever we have this type of situation, then we define the external composition. So I hope you have understood what is the internal composition and what is the external composition. Tomorrow we will define vector space properly, and we will consider that algebraic structure in which we have two composition. One is internal composition and other is external composition. Thank you. Jai Hind.